Hello, ladies and gentlemen. If I could have your attention, please. Now, obviously, I don't need to say that since this is a video presentation, but I just want you to get used to when we're back in the classroom, one of the first things that I always say to start a class is, may I have your attention? And then everyone stops what they're doing and gives me their attention, and then we can begin. So once I have your attention, we're going to start with a very interesting question today in math, and that is, how is math like riding a bike? I'm sure most of you have ridden your bikes all summer. You've had a wonderful time doing that. Riding bikes is fun. Is math anything like riding a bike? I don't know. Let's think about that. All right. The first thing I want you to do is I want you to take out a piece of paper. Okay, I'll give you a second to do that. Grab a piece of paper, number 1 through 4 or 5 or something. And I want you to think about, when you ride a bike, what are some of the steps that you are required to ride a bike? Okay, so I'll give you a few minutes to think about that. Write those down. All right, so some of the things that you might have said, you have to put up the kickstand, you have to swing your leg over, you have to put one foot on a pedal and kind of push down, and then you kind of put your butt up on the seat and you push the other pedal and you start riding, right? Easy. Now, here's my question. These are the steps to ride a bike, and you could study them and you could memorize them, and if someone had never ridden a bike before, you could even demonstrate these steps for that person. But I have a question. If you had never ridden a bike before and I had you memorize these 4 steps, could you just get on the bike and ride it down the street? I don't think so. So I want us to think about this. Do we think about each of these steps every time we ride a bike? I would say the answer is no. We know how to ride a bike, we've learned it, our body knows how to do it, it just comes naturally. It's kind of a deep learning, something that we've learned deeply. We can just ride that bike. So what I want to propose to you is, how is math like riding a bike? Or can math be like riding a bike? Now you might say, well, it isn't like riding a bike because, like we just said, we don't follow certain steps every time we ride a bike, we just do it, we just ride it. In math, for example, if I were to give you a problem like this is a problem that we will do at some point this year. Find the volume of this figure. You might say, well, I don't know how to do that, I need the steps. And I could say, well, you have to, step 1, you have to use the volume formula for one section. Step 2, you have to multiply this times this. Step 3, you have to add those together, etc. Okay? But what I want to propose to you is that instead of just doing steps every time, steps are good, but if we just memorize steps every time, when we come to a new problem similar to this, we have to stop and think, now wait a minute, what steps do I need? Were those the steps for this kind of problem? Were those the steps for this kind of problem? So what I want to do, what I want to propose to you this year is that we are going to do math by riding the bike. Of course, we will talk about steps. Sometimes we learn to ride by thinking about the steps. We learn to do math, but what I propose is that we're going to look at deep learning, learning the concepts that are underlie volume. Volume is just finding the area of the base, it's filling the figure up. How much does it take to fill that figure? And if we talk about volume and learn what volume really means, then when we come across a new problem, we can use that deep learning, and we don't have to go back and think, okay, what were the steps for this problem again? So what I want us to do this year, what we are going to do is we are going to look at learning math deeply. Now, how do you do that? How do we learn math this way? Okay, one of the big things is we're going to visualize. We're going to use manipulatives, we're going to use pictures, we're going to visualize what's going on. This is what's going on in solving an equation. I'm sure most of you solved equations last year. I don't know, did it look like this? All right, use patterns. We're going to look at numbers. We're going to look at patterns. What happens when you count by every even number, and what happens when you look at all the prime numbers? What's the pattern on the grid there, for example? We're going to do notice and wonder. One of the things we'll talk about this year is a dragonfly. How fast does it fly? What is its miles per hour? And how does that help us to determine what's going to happen after or how far the dragonfly can go in, say, 5 minutes. We're going to use that to solve problems. Noticing and wondering. What do we notice and wonder when we look at a certain problem? We're going to make mistakes. Mistakes is where your brain grows. Okay, that's how your brain gets stronger, is by making mistakes. We're also going to do activities. Okay, activities are something I really like to kind of get our hands dirty. Now, online, it's going to look a little different than it will in the class. In the class, we'll actually get things out and work with them, but we'll also do it online. So that's another thing we're going to do. All right. Now you might say, okay, that's great. We're gonna actually do math. Well, aren't there just some people that are good at math and some people that aren't? Well, I've heard that a lot, but I want to encourage you that that is not scientifically true, that some people can do math and some people can't. Some people can do math because of maybe the experiences they've had, but math is something that if you work at it, you can do it. It all has to do with your mindset. So let's take a look at something here on, hopefully.
That what you have believed about your own potential has changed what you have learned and continues to do that, continues to change your learning and your experiences. So how many people here, let's get a show of hands, have ever been given the idea that they're not a math person or that they can't go on to the next level of math, they haven't got the brains for it? Let's see a show of hands. So quite a few of us. And I'm here to tell you that idea is completely wrong. It is disproven by the brain science, but it is fueled by a single myth that's out there in our society that's very strong and very dangerous. And the myth is that there's such a thing as a math brain, that you're born with one or you're not. We don't believe this about other subjects. We don't think we're born with a history brain or a physics brain. We think you have to learn those. But with math, students believe it, teachers believe it, parents believe it. And until we change that single myth, we will continue to have widespread underachievement in this country. Carol Dweck's research on mindset has shown us that if you believe in your unlimited potential, you will achieve at higher levels in maths and in life. And an incredible study on mistakes showed this very strongly. So Jason Moser and his colleagues actually found from MRI scans that your brain grows when you make a mistake in maths. Fantastic. When you make a mistake, synapses fire in the brain. And in fact, in their MRI scans, they found that when people made a mistake, synapses fired. When they got work correct, less synapses fired. So making mistakes is really good. And we want students to know this, but they found something else that was pretty incredible. This image shows you the voltage maps of people's brains. And what you can see here is that people with a growth mindset who believed that they had unlimited potential, they could learn anything, when they made a mistake, their brains grew more than the people who didn't believe that they could learn anything. So this shows us something that brain scientists have known for a long time, that our cognition and what we learn is linked to our beliefs and to our feelings. And this is important for all of us, not just kids in math classrooms. If you go into a difficult situation or a challenging situation and you think to yourself, I can do this, I'm going to do it, and you mess up or fail, your brain will grow and more and react differently.
I'm going to stop the video there, ladies and gentlemen. That gives you the idea that it's in the struggle that we grow and learn. That's how our brain grows, and making mistakes. So what I want to kind of leave us with today are some things that we are going to really focus on this year in math, and that is these ideas. If you start out knowing how to do it, your brain isn't going to grow. Now, it's great if you already know how to do it. If you already know how to solve every kind of equation, that's great, okay? But please do not be afraid of the struggle, because it is in the struggle that your brain is growing. Don't give up in the struggle. Making mistakes make your brain grow. We're not going to be afraid to make mistakes in class this year. All right, ladies and gentlemen, that is what we are starting with this year with. Now I want you to go back to your Google Classroom assignments. You have some directions on how to set up a Google Drive folder in your Google Drive for all the notes and things that we're going to be putting in there. Okay, so we'll see you tomorrow.